Welcome to Quantum Racer. This game was designed to teach students about the concept of noise and decoherence in quantum computing. Let's take a look at the instructions. I know they're a little verbose, but we'll try to go over them as fast as possible. This is a game, a simple racing game. How to play is avoiding the obstacles and reaching the end as fast as you can. You are in a quantum world, and there's a couple concepts we need to explain before we get started. The first one is superposition. Superposition is a property that allows your quantum states to exist in two states at once. And so, in this game, we have it so that the car will be sent into superposition randomly. And then your car will exist in two states simultaneously, one staying still, and one that is continuing to move. Then we must talk about quantum measurement. It's different from classical measurement because it collapses that superposition that we just talked about back to the base states. After we put you into superposition in this game, you will be randomly measured, and it will be either sent back to the stationary car that was split apart initially, or the moving car that's continuing to move. If the stationary car is measured, of course, all the progress you've made so far is lost. This is one of the key aspects of superposition and why measurement is so important. Now, obviously measurement is not completely random. There is this concept in quantum measurement called the probability of measuring each state. This is because different states in superposition can have higher contributions than another. And when you measure these states with higher amplitude, the one with a higher amplitude will have a higher probability of being measured. Therefore, you can collect these probability tokens that we've placed into the game. And by collecting them, you can increase the probability of staying where you are and not losing your progress. And now finally, we've covered those. I'd like to talk about noise and decoherence, the primary concept in our quantum car game. Quantum decoherence and noise are the biggest limiting factors on modern quantum hardware. It's the loss of quantum information. Now, in this game, we've represented this loss of information by these little blue circles called decohering particles. And if you do crash into them, you will go slower. Your quantum information collection will slow. And it also jumbles quantum states. Now, when you are in superposition, what that means is you will lose visibility, but not only that, your probabilities will become completely mixed up, because that's what noise and decoherence do to quantum states in the real world. Think in a quantum computer, you have some sort of state, and you're very carefully monitoring it. Some wave, a microwave, your phone being used in the same room, any of these things can disrupt the quantum state and ruin it, and then all the information that you've so carefully gathered will be lost. Now, hopefully you've understood about the quantum world through this explanation. If not, let's walk through the game and see how it works. With that, let's get started. So as you can see, these little blue particles that you see here are the quantum decoherence particles. I'm going to control my car by trying not to hit them, but let's see what happens when I do hit it. As you can see, the visibility gets reduced and you go into this state of disorientation where your car starts moving more slowly than before. Let's keep going and let's see if we encounter any sort of superposition that appears soon. Well, once again, I've crashed into these and it's showing me a lot of noise. Let's see about some superposition. Yeah, there you go. You see superposition in 3, 2, 1. And now that car just split, and I'm going to be trying to collect these probability tokens. And as you can see on the bottom, it says the probability of clearing the obstacles is 100% right now because I've collected so many probability tokens. Let's see what happens when I crash into one of these decohering particles. It resets my probability of clearing back to 0. It's quite awful. But I'm going to try to make, got reset again. Let's try to keep collecting these particles so that I don't end up being sent back. And now we've been away from our stationary self for a while. Oh, we're at 90%. This is very good. Ooh, perfect. See, that just cleared the screen for us. Got rid of some obstacles, and we didn't get sent back. The next time superposition comes around right now, I'm going to try to express what happens when something goes wrong. So as you can see here, I'm going to try to mess up as much as possible so I can show you guys what happens when I get sent back. Right, the probability of everything being cleared is 0%, and the probability of going back is 100, which is what I'm trying to demonstrate. Let's keep crashing into these particles and getting stuff wrong. This is not what I'm supposed to be doing. I would like to not do this. Let's see. Soon I'll be measured and this problem will resolve itself. Set measurement in 3, 2, 1. And see that progress bar going all the way back. I just started over from where I initially got split. Now, this time in superposition, I'm going to try my best to not do that because I would like to... Oh, I got measured already. Got sent back again. That was unlucky. So, just demonstration of the challenges with quantum superposition, you see that even with a 50-50 chance, right after going into superposition, I immediately had some issues. Ooh, when I instantly crashed into stuff, that was not good. Let's try to grab some of these. Oh dear. Oh, I got lucky. See that? That 30% probability really helped me pull through there. Okay, I'm avoiding these obstacles. Almost at the end of the race. Oh, okay, this might not be good. I just got sent into a superposition. Oh, we reached the end. Good. Alright, time was 183, which is around 3 minutes and 3 seconds. And that concludes the demo of our game. See our high scores here. I got 170 some time ago. Now I've gotten 183. Thank you for watching our demo of Quantum Racer. I hope you learned something about quantum noise. And if not, feel free to check out the Qiskit textbook through IBM, or just Google it. There's plenty of amazing resources online to learn more about quantum computing. Just some credits at the end. This game was made by Maribel Chu and myself, Karthik Tyagarajan, for International Quantum Day. It's to teach more people about quantum mechanics and to pique your curiosity about the subject. It's not supposed to be a thorough, accurate representation, but with that, I hope you enjoyed. Thank you.